Hello, my name is Connor. I'm a software engineer at Mesosphere. I work primarily on Marathon, and that's what I'm going to be talking to you folks about this afternoon. Just a preview of where we're going. First, we're going to start with some basics, and then we'll dive into some more advanced features, which is probably the meat of what you want to see. We'll end with some Q&A if you have any questions. OK, I'll jump right in. So here's a common problem. We're at LinuxCon. You probably have some Linux applications. So how many of you need to run N of something on M machines occasionally? Yeah, that's everyone. OK, what about changing N? So if you want to scale up, scale down. What if you want to change the number of machines you're deploying across? How do you handle failures? Toby talked a little bit about this. You want to make it easy for ops to handle failures in your infrastructure. What if you want to increase utilization by using your cluster for more than one type of workload? So Marathon is for long-running services. But if you're running on top of Mesos, you can also run, for example, Spark that Paco just talked about, co-resident in the same cluster. And you can drive up utilization that way. So let's say hello to Marathon. It's a solution for running applications in your data center. It's a self-serve interface. So the idea is that your ops people or your developers can just go to Marathon and submit your application, description of your application. And then Marathon just uses resource offers from Mesos to deploy it on your cluster. In this way, it provides sort of a distributed init or an upstart system for the data center operating system, as far as you want to take that analogy. OK, so some high-level concepts. Commonly, task in Mesos is mapped one-to-one with a Linux process. That's not necessarily the case, but more often than not with Marathon, that's what we're talking about. So it introduces the concept of an app, which is an abstraction over a collection of tasks that's running on a Mesos cluster. So you provide a description of your app, and then each instance of your task is actually a Mesos task or a Unix process. And then Marathon actually takes care of all the launching of that for you. And allows you to introspect where they're running and how many are up, how many are healthy. And we'll take a look into exactly how we specify that to Marathon. Just taking one step back, here's the Mesos model, way simplified and in picture form. So the big M on the left is the Mesos system encapsulated. The scheduler on the top right is the part of the framework that receives resource offers from Mesos. So Mesos is aggregating the resources of all the slaves, making offers to the scheduler. And the scheduler is going to call launch task and execute things on the cluster. So just swapping in a little more Marathon-specific picture of that. Like any other Mesos scheduler, it's receiving resource offers from the cluster. We also expose a REST endpoint. And this is the way that you provide the description of your application. So you provide a description that says, I want to run 10 copies of this application. And then Marathon will compute a queue of tasks to run. And it drains that queue using the resource offer stream from Mesos. So pretty simple concept. OK, let's jump into the basics of how to work with this. First thing you want to do is launch an application. It's as easy as a post, HTTP post to an endpoint, v2 apps. Providing some basic data here. It has a name. It has a command to run. In this case, it's just distributed sleep or single node sleep, so not super interesting. But this could be any Unix command. We also supply the number of CPU shares. This is a fraction of CPUs. And Mesos will take care of the allocation and the isolation of this for us. The amount of memory you want allocated to each instance, and then the number of instances. So this is the bare minimum if you want to launch a command somewhere on a Mesos cluster. It can be this simple. The next thing you might want to do is to scale up or scale down. It's as easy as a put. And you can just supply a partial application definition. In this case, we're just updating the instances member from 1 to 32. And assuming you have enough resources in your cluster, eventually those tasks will all start running. OK, the next thing you might want to do is look at what apps are running in your cluster, or running on Marathon. So it's just a get to the apps collection. And this is a full application definition with all of the things that could be in it. It's a little small. We're going to go through it piece by piece. Just to back up a little bit, Marathon has the common REST endpoints you might expect when you're working with apps and tasks. So you can do a put to a specific app to do an update. You can get the running tasks for an application. You can do a delete against the task ID to kill that instance. Or you can do a delete against the app to kill all the instances and completely forget about that application. It also has a pretty nice UI. So this is the new application form. If you want to just supply a basic application definition, you can fill out this form and hit create, and you're done. Here's an example of a list of running tasks for an application. And you can see on the far right, there's the very last column is labeled health. And you can see we have a bunch of green balls there that shows us that all of our app instances are healthy. All right, so that's the basic usage of Marathon. Let's jump into some new stuff. One thing you might want to do is affect the scheduler to decide where tasks are placed in your cluster. So one thing you can do when you start up the Mesos slave process is you can supply attributes. So you can say this thing has fast SSDs or some special attribute that you might want to hang off of when you're scheduling tasks. And those things are exposed through the resource offer that Marathon receives. And you can affect how scheduling decisions are made in Marathon by supplying constraints in your app definition. So we have 3 operators available. One is called unique. So this first example is saying, let's schedule things such that hostname is unique across all tasks. That means run at most 1 copy per host. You might want to do that. Depends on your use case. Another constraint is called cluster. So this means, if possible, schedule tasks such that they're co-located with an attribute that has this value. So this means we want to schedule as many instances as possible in rack 1, assuming you have some attribute called rack ID. Kind of the dual of that is called group by, where we're saying group by the value of the rack ID attribute. We're saying like if we have 5 racks and 10 instances, we should get two instances per rack. It's just one way you can spread your tasks around the cluster. Health checks is a pretty useful feature. They come in 3 flavors, the first of which is HTTP. We see the definition here. We have to specify the protocol. And then the port index is the index into the array of randomly assigned ports that you get from Mesos. And we can add a path. So it's pretty easy to see how the URL will be built up here. We have the host name, the port, and then the path that you supply. And we have max consecutive failures, after which your task will be killed. The grace period is a way to allow a period after the task starts that it's OK for it to fail health checks. Maybe it has to do some boot up that commonly takes a long time. You might want to give it a break for a little bit before you start making sure it is passing health checks. And then interval and timeout, I think, are pretty self-explanatory. So the second flavor is TCP. It's largely the same as HTTP. It just tries to do a socket open against that port. So the first 2 varieties of health checks are actually executed by the Marathon scheduler. So the scheduler is actually making connections to all of your tasks, which is not necessarily ideal if you have a big cluster. So one great feature in recent versions of Mesos is the ability to execute health checks on the slave. So the Mesos core has support for health checks now, and Marathon exposes that functionality. So to use this, you have to set a flag when you start up Marathon called executor health checks. And then you can use the command protocol. You can supply a command. Here we're just doing curl-f, where the -f means exit with a non-zero status if you land outside of some acceptable range of HTTP status codes. So if you're not in like 200 to 399, curl will return with a 1 instead of a 0, and the Mesos slave interprets that as the task isn't healthy, and that information is propagated back up to the scheduler. Okay, assuming you have health checks defined, if you query a task, you can see its health check results. You can see whether it's currently alive, how many failures how many times it's failed consecutively. Hopefully that's 0. The timestamp of the first time it became viable, so the first health check it passed, when it last failed, the last time it succeeded, and just the task ID, so duplicated there. Rolling deployments are another cool feature. I think Toby mentioned this in his talk about distributed ops, where we have this attribute on an app called minimum health capacity. So 1 means we always need the requested number of instances healthy. So we will start 1 copy of the new version outside of that, and then once it becomes healthy, we can kill one of the old one. If you set it to 0.5, we can drop down to half of the requested number of instances, and then build back up with the new version. So that's a way to tweak how the deployment happens. And these things are actually, so when you do an update to an application now, you lock the application for future updates, and you get a deployment ID, and there's a deployments endpoint where you can actually monitor the status of the rolling upgrade. If you want to cancel it, you just do a delete against the deployment. Okay, so in previous versions of Marathon, we had just a flat namespace of applications. In the next version, which will be cut soon, it depends on Mesos 20, so as soon as that's tagged, like today, we'll probably we'll release an RC1, allow some time for testing and feedback, and then eventually we'll have a release with all these features in it. So you do a put against V2 apps to create an application. You can actually create a multitude of applications at the same time. And you can see in the ID, we can define a tree or a hierarchy using slashes. So here we have two applications, one of which is called beta product A front-end sample app, and it depends on beta product A backend. So if you were to do a scale operation against beta product A, it first scales beta product A backend and then scales the front end to make sure that you have enough backend capacity to handle the traffic. Exponential backoff is now configurable per application. This is a way to guard against flapping tasks. So if you have an app configuration that's no good, it's never going to become healthy, those failed tasks have the potential to fill up the disk on your slave, for example. And this is a way to prevent that. So it starts off at 1 second. So if you have a failed launch, the next one will be delayed by a second. If it continues to fail, that timeout will be multiplied by the backoff factor. So 1 times 1.15. And that quickly increases to a maximum of 1 hour right now. Artifact caching is a pretty cool feature. So one problem when you're deploying onto like many nodes is that your URIs are going to be downloaded by every slave. So one way around this is you can supply your URL as a store URL. And if you have the artifact store turned on, it'll first download it, put it into the highly available store, and then translate the URI that is sent to the Mesos fetcher. So the fetcher will actually download all of your artifacts from HDFS instead of HTTP. Docker support. So this is in Marathon Master, and it'll be in the next release as well. But in order to use this, you have to supply the containerizer's flag. as Victor mentioned in his talk. So a nice way to do this is to say Docker, Mesos. This allows you to use both the Mesos containerizer and the Docker containerizer. And then we have this container field. It takes a type. The only supported type right now is Docker. And then we have a Docker field where we can supply an image. So here we're running this Python command in this Python version 3 Docker container. So the slave will do a Docker pull, and the executor is actually run inside the container, which is pretty cool. It doesn't stop there. We also support the alternative way of invoking Docker, which is to use the entry points. So there's another field called arguments. So you either supply command, which wraps your command in an sh-c, or you supply args, which appends the array contents to the entry points. So in this example, we have this image called mesosphere/inky, and the entry point here is cat. So we're saying cat, hello, or no, it's echo. That makes more sense. So we're saying echo, hello, and then that's the command that Docker will execute. It also has support for volumes, as mentioned, but this is what it looks like in the Marathon JSON. So we have this volumes field as a container path, a host path, and a mode, which is either read-write or read-only. So, all right, that was all the features I wanted to run through. I know there's a lot of content, but if you have any questions, be happy to field them right now. Private registry. So you can set that up by pushing config to the slave, or you can add a Docker config URL to the task, and the Docker containerizer will use that for your credentials.
Can artifact caching do Docker containers?
It's not set up to do that right now. The containerizer uses the default Docker registry, so.
Oh yeah, so there's a way to kind of tell an application it should all cluster on one node or be spread across the data center. Is there a way to tell a set of applications they should all be deployed together, a set of different applications? Or is this just on a per application kind of basis?
Yeah, there's no support for that currently in Marathon, but
is that planned?
Let's. I know John is going to talk about that idea in his keynote with his idea of pods, which is a great idea. I agree.
Thanks.
For those command-based health checks, where do those commands actually run? Do they run within the same container as the executor, or are they running like off the end of the slave in its own unique container?
Those run on the slave, I believe. I might have to double check that though.
Can those health checks be configured to look for specific output of a curl command, for example, or is it just 1 or 0?
You can do whatever you want in the command. So it's an arbitrary Unix command. That command can even have URIs, I think. So you can download artifacts, like a program that you want to run against your app. But all Mesos does is it does a wait and looks at the exit status. So.
For the Docker support, you showed the example of like mounting volumes. Are you able to pass additional Docker flags like setting host name or setting environment variables, things like that?
Environment variables are supported. So that's part of the regular format, and that actually works inside the container as well. But as far as other Docker-specific attributes, I think that's maybe for the next iteration of Docker support in Mesos.
What's on the roadmap for Marathon? Like what new features are you looking to add?
I'm not sure yet, actually. So this is, a really big push, like big raft of new features. I think it's going to be, stabilization, documentation. One thing I noticed on the roadmap is a UI revamp, because there are a lot of features in the REST API that aren't available in the UI right now. So exposing that, I think, would be good for user experience.
Question over here. The constraints, you were mentioning one where you can specify that one or some specific number of instances run on a given slave. Was thinking about, would it be possible to specify that you want to have every slave run one instance of something? And what would you do to do that? Where you, in other words, if you specify the number of instances, that's a static value, but let's say you have new capacity being added to your cluster at any given time. You just want everyone to do that. Or is that not the right approach for this kind of thing?
You can do that, but not just with Marathon. So there's an idea of resource reservations on the slave and roles. So you can tag slaves and then make sure that there are resources available for a specific task.
Let's thank Connor. Thank you.